Hey, y'all video started. Okay. So today we are solving two-step equations. So we've been busy solving one-step equations where we purely just looked at the inverse operations. I'll be honest with you, I bet you can fill out the top of your notes all on your own. I bet you can. First things first, we need to remember our integer rules today. Big time remembering today for all of them. Because we're going to be doing two-step equations, which means we're going to be doing multiplication and division and addition and subtraction. Okay, we're going to be doing both of those today. So, remember your wrap, same sign, add, different sign, subtract, and keep the sign of the bigger one so you can be exact. What? Good, and don't forget, keep change the signs. Good, and the last one, same sign, positive, different sign, negative. Don't forget all of our songs and our raps for today, okay? It's going to be important. Now, I bet you guys can fill out the top, right? We know what it's going to be. It's all about Elsa, right? When solving equations, our goal is to isolate that variable. Exactly. Let's get that written because we know this. We're going to write it so many times, you guys are going to know exactly what to do. How are we going to do it?
Inverse operations.
Use inverse operations, right? That's what we're going to be doing. Now, quick review where you're going to need to listen, right? Quick review where you're going to need to listen. Do you guys know that sometimes I watch the video? All right, just to make sure that it's the right length and stuff. I touch my glasses a lot. I usually go left and right a lot. Did you guys notice that?
Yes.
It's the drummer in me. You know? Drass, you a drummer?
What?
Are you a drummer?
A drummer?
Yeah. I don't know why I thought you were a drummer.
I'm a pianist.
Yeah. Anyway, I've been a drummer, so a lot of times drummers don't ever stop moving their hands. It's just how it goes. We just constantly. Anyway, quick review here. We need to remember this. It's very important. What are the order of operations, right? PEMDAS. Please excuse my dear Aunt Sally. Notice, remember, when we get to parentheses, exponents, multiplication and division from left to right. It's not always multiply first. Okay? Add and subtract from left to right. It's not always add first. Okay? So here's the big key. We've got our order of operations, right? Not really. Here's the deal. With the order of operations comes into play when we simplify. Okay? When we simplify, everybody look over here to the right. You won't see this on the video, but, you know, sorry. When we did number one, when we plugged in -3, what was that inverse operation? What did we do first? Based on order of operations, which part did we do first? Multiplication, and then we did the addition or subtraction, right? Well, here's the deal. When you're solving two-step equations, aren't we undoing everything? Don't we want to get the variable by itself? We're using inverse operations, right? Wait, if we're using inverse operations, shouldn't we use the inverse order of operations as well? Here's the deal. First thing we want to do, okay? We actually want to undo the addition and subtraction. That's the first thing we want to do. We want to undo the addition and subtraction because that's what the inverse of the order of operations is, right? It's the reverse order. Inverse kind of means opposite, right? Kind of. Not exactly, but it's kind of like the opposite. So if we're using inverse operations, we should use the inverse order of operations when we're solving equations. So we would use subtraction and addition first, right? Or we'd use its inverse first, right? And then the second step, what do you think it's going to be? And then multiplication and division. It's the inverse of what you have learned. Because solving equations, we want to isolate that variable. We don't want to combine like terms. We don't want to simplify. That's the big difference between two different directions. The direction simplify, which means use order of operations to combine your like terms. And the direction solve. Solve means get a variable by itself using the inverse operations, right? Remember, inverse operations. Inverse are those operations that undo things. Yes, ma'am?
If you're doing inverse and there's an addition and a subtraction is a problem, which would you do first?
Great question. We'll get to that in a few days. But to answer that question is whatever one you want. Yeah. Or you can combine them first. You could combine like terms and then move them over. It's up to you. It's kind of like that perimeter problem. Remember the perimeter problem from our word problems? How there were 3 numbers? There are several ways you could do that problem, right? You could subtract the 5.2 to the other side. You could subtract the 8. and then you'd have the x. Or you could combine those two and get 13.2. The people who did problem number 5 in the homework know what I'm talking about right now. Then you can move that over. So you got choices. But for right now, we're going to try to keep it simple. Okay? Here's the big idea that we want to keep in mind. When solving equations, we use the inverse or opposite operation. So you also do the order of operations in the opposite order. Right? That's the idea behind what we're doing. All right? So let's try some. We're going to write our steps. Remember those steps? Build a wall, circle the barrel, all that stuff? We're going to write those steps up here. If you have room, it's probably to the right. We aren't going to do number 2.
Okay.
We might do number 2. First things first, what should we do? Build the wall. Right? Build that wall. Number 2. Close. Here's the change. So Ashley said circle the variable. Here's the small change. Okay? We're going to circle the variable and its coefficient. We're going to circle everything that's with the variable this time. So on number 1, what are we going to circle? Not just n, but 5n. What if it was a negative 5n? What would we circle?
The negative 5n.
Negative 5n, right? We circle the variable and its coefficient. Okay? That's the change, the big change. Because now it's pretty obvious what we need to get rid of. It's the stuff that's outside the circle, right? What stuff do we need to get rid of? Well, it says 5n minus 5. What's the inverse operation of that?
Addition.
Adding 5. So step 3 is use the inverse operations on both sides, right? What was that inverse operation for number 1 that we needed to do? So right now it says circle minus 5, right? Remember that circle? We're not going to do anything inside that circle right now. Okay? It says circle minus 5. What do we need to do then? Inverse operation of circle minus 5 is circle plus 5. So we need to add 5 to both sides. Now, I always recommend canceling out on the left. What's going to cancel? Minus 5 plus 5, right? Negative 5 and positive 5. Boom. They cancel. Because now what's left on the left? 5n, that stuff in the circle, right? Remember how we said this is a 2-step equation? We've just done 1 step. Now, this equation we've seen before. You with me on that? We've seen this before. So I like to think about the stuff inside the circle as they're kind of a thing, you know? They're kind of a thing, right? That's why they go in the circle together. They want to be left alone. Right? Leave me alone, Mom. Right? It's like your mom's like, leave the door open. And you're like, oh man, do I have to leave the door open? Leave me alone, Mom. So 5n, they're kind of a thing, right? They're kind of a thing. Well, now that they're by themselves, they've been by themselves too long. You ever been with somebody too long, you just start fighting with each other? They're your best friend, right? You with a good friend, right? You probably don't. But with a friend who like stays the night like 2 nights in a row, you kind of start to bite each other's heads off, and it's time to go your separate ways and have some space. So here's the deal: they've been alone for too long. 5 and n. They need to break up.
No.
So they're together, right? They're together inside that circle, but now they're not inside that circle anymore. They're not inside that circle. They need to break up. So step 4 now is they got to break up. 5 and n, they're together, right? They're an item. That's why we circled them together. They're an item. You guys know any couples in school that are an item? You know, when you think of one, you automatically think of the other. Yeah, sometimes. Yeah. In my school, it was Dan and Aaron. Not me, but it was a girl, Aaron. E-R-I-N. Dan and Aaron. Whenever you invited Dan to something, you had to invite Aaron. Just how it goes. They were a couple. They were a thing. But they, in the end, did not get married. They had to break up too. Right? So how are we going to break them up? How are we going to break up 5 and n? We're going to use the inverse operations again. What inverse operation is that?
Division.
Yep, I'm going to divide both sides by 5. I recommend canceling. I recommend canceling. Why? Because what's left over?
And
N. You can see it's the only thing that's not crossed off. Those of you who don't do that crossing off thing, you don't necessarily see that something is canceling. All right? So what's left on the left? And what's left on the right? 20 divided by 5 is 4. And that is our answer. So did we see our 2 steps that we did? I tried to highlight it with the red. You see that with the red? Our step 1 is get rid of the addition or subtraction. We undid the addition and subtraction. Step 2 is undo the multiplication or division. Okay, there's step 2. Yes, Ashley?
Number 4 says,
They break up.
and then it says inverse.
Yeah, if you don't want to write they break up, you can just use inverse operations again. But I like to think about them as a thing. You know, we circle them, we put them by themselves together. They've been together too long at the end, so we got to break them up. They're attached. All right? So, I'm going to go a little faster through number 2 because I think you guys can do this one now that we have the skills. So, the first thing I do is build a wall. The second thing I do is circle the variable and its coefficient. So, circle the variable stuff is a lot of times how I think about it. Jeremiah, question?
No.
Okay, you sure? Okay. This is the time to ask if you're confused. Remember, we've only done one example, so there might be a little bit of confusion right now. Let's try to think through some of these next couple ones. All right. So I circled the variable and its coefficient because it's a 2-step equation. How do I know by looking at a problem that it's 2 steps? It has both multiplication and division, and addition and subtraction. Okay. Those are the 2 steps. All right. So I need to use the inverse operation on both sides. What inverse operation is happening to that circle? This says circle. What's it say? It says circle. Nope, this says circle. What does it say? Circle plus 12. So the inverse operation would be circle minus 12. So I need to do minus 12 on both sides. Cancel out, right? Please do that canceling step. If you don't, it's not obvious what's left. What's left? What hasn't been crossed off?
8n.
8n, exactly. That's our step 1, right? That's step 1 of our 2-step equation. So now we have 8n equals what? 36 minus 12 is 24. So now, they need to break up now. What do I need to do? This says n times 8. The inverse of that is divided by 8. The 8's will cancel because 8 divided by 8 is 1. What's left on the left? And what's left on the right? 3. All right. And that was our step 2. Okay? So here we go. We're going to do 1 with division, and then I'm going to kind of release you and see how we do. Okay? We'll do 1 with division. So, of course, we do the same steps. The only thing that's different about number 3, I'll let you decide. What's the only thing that's different about number 3 than what we've done so far? Ashley? It's division instead of multiplication. I bet it's going to be the same process. Step 1 is build that wall. Step 2 is, now here's where people get confused. They're like, what's the coefficient? Technically the coefficient is 1/3. Let me show you why. What's 1/3 times n over 1? 1 times n is? 3 times 1 is? Hey, look at that. So technically the coefficient is 1/3, which means that when we circle the variable and its coefficient, we circle the variable and the thing it's being divided by. Because that is technically its coefficient. That's why I like to think about it as the variable and its stuff, right? The variable and its stuff. All right? So, use the inverse operation on both sides. What inverse operation am I going to use?
But it is minus.
So this says circle plus 6. I want it to say circle minus 6 on both sides. That's going to cancel. And I'm left with what's left on the left.
N over 3.
N over 3 equals, now, 3 and negative 6, that's my wrap, right? Same sign. Add. Subtract, keep the sign of the bigger one so you can be exact. This is why we need to do that wrap a lot. Here's the deal. Repeating the wrap doesn't do anything unless you're actually listening to what the wrap says, right? We got to listen to what the wrap says. All right, now I start the process again, right? They're going to break up. N and over 3 are going to break up. We need to use the inverse operation again. This says n divided by 3. I need it to be
And multiply by.
times 3 times 3. What's left over? N. What about on the right? Same sign, positive. Different sign, negative. Cool? All right, you guys and you and your partner do number 4. Go. Talk it through, steps wise. You and your partner do number 4, step wise. Once you and your partner agree on an answer, take a look up there. This says -2, -2, that doesn't work. Whole point is +2. I want you to try 5 and 6. 5 looks a little different though, doesn't it? Yeah. Is that going to mess you up? No. Hey, inverse operations, right? What's the only difference about number 5?
Negative.
That's true, there's a negative on the bottom. That wasn't what I was looking for, but that's true. Yeah, the variable's on the right. So when you build your wall, where's your circle going to be? On the right side. That's not a problem, right? That's not a problem. It says circle. What does it say now? It says circle. What does it say, everybody? Circle.
-8.
Good. We need it to be the inverse operation because we're isolating that variable. So the inverse of that would be circle plus 8. Okay. Number 6 is going to have a fun little answer. All right? This just means that you're going to have to divide by something. You have a fraction. It's not a fraction. Not a big deal. Not a big deal. Good. I like your setup. That's awesome. I love that you have a good setup there. Good. Yep, that will be 0. That's perfect. It should be, right? It should be 0 when you cancel out the adding and subtracting. Great. No. Where's the m? It says we want it to be circle minus 8 squared circle plus. Right? So we need to add 8. Because over here we did circle plus 6, we did circle minus 6. Circle on the right is okay. We just have to get rid of the stuff on the right. Remember, we don't change any size. We never change any size. We just inverse. So if we're multiplying by 8 and 5 and inverse, the way we can remember that is you already understood the addition. Now you're going to do multiplication. And sine of multiplication. Got it right.
Oh my gosh.
All right, look up once you've done number 5 and number 6. Hey guys, one thing that people often mess up is the signs, right? A lot of people mess up the signs. Let's look at number 6 for just a quick second. If you don't divide by -5 here, what's going to be left over on the left side? What if it's -5x divided by 5? What will cancel? Just the 5s, leaving -x. We don't want -x, we want x, right? So we want to make sure that the negatives will cancel too. So that might be helpful to do. Make sure that you cross off the negatives as well. That might be a helpful step to do when you're doing this division. It might be a helpful step to do is to cross off that division. Ashley?
For the negative, when you got negative 21 over -5.
Yes.
But is it okay if you just turn it into an exponent?
Yeah, I think it's easier to leave it as fraction though, because how many times does 5 go into 21?
4 times.
With a remainder of
1/5.
1. With a remainder of 1. So if you have a remainder of 1, you just put it over the denominator. Now we're not going to have time to do number 7 and number 8, but we're going to address those tomorrow. I bet you know what to do though. Get rid of the adding 7, and then multiply by the reciprocal, right? I bet you'll be able to do that, right? So your homework today